Mount Pinatubo ejected 20 million tons of sulfur dioxide into the stratosphere in 1991, lowering global temperatures by half a degree Celsius for nearly 2 years. This natural experiment provides the foundational proof of concept for stratospheric aerosol injection. Aerosols increase Earth's planetary albedo by scattering incoming short-wave solar radiation back into space before it reaches the troposphere. This reduces the net energy absorbed by the surface without directly altering greenhouse gas concentrations in the lower atmosphere. Sulfur dioxide reacts with water vapor in the stratosphere to form sub-micrometer sulfuric acid droplets. These tiny particles are sized perfectly to maximize scattering, ensuring that the maximum amount of solar energy is deflected per unit of injected mass.
Modified high-altitude aircraft are the most feasible delivery method for these aerosols. Current jet designs must be optimized with high aspect ratio wings and specialized engines to maintain lift and efficiency in the thin air of the lower stratosphere at 20 kilometers. Unlike tropospheric pollution that rains out in days, particles in the stratosphere remain suspended for 1 to 2 years. This longevity is due to the lack of vertical mixing and precipitation in the stratified layers of the upper atmosphere. Sulfate aerosols provide a surface for heterogeneous chemical reactions that can activate chlorine compounds. This process accelerates the destruction of the ozone layer, potentially increasing ultraviolet radiation exposure for life on the surface beneath the injection zones.
Artificial cooling does not reverse climate change uniformly across the globe. Some climate models predict significant shifts in monsoon patterns, particularly in South Asia and Africa, which could disrupt water supplies and agricultural cycles for billions of people. If an injection program is suddenly halted, the suppressed greenhouse warming would manifest rapidly. Global temperatures could rise by several degrees within a decade, a rate of change far exceeding the adaptive capacity of most ecosystems and human infrastructure. Relying on a technological fix may reduce the political will to pursue essential carbon decarbonization. This moral hazard creates a risk that societies will continue emitting fossil fuels while dependent on a temporary and fragile solar shield. There is currently no comprehensive international law governing the use of the stratosphere for geoengineering. Establishing a multilateral oversight body is essential to prevent unilateral deployment by individual nations that could lead to geopolitical conflict and atmospheric instability.